Hi, welcome back to the another lecture in process control automation. This is Nagarjuna, and today we will discuss about the ladder logic programming rules and addressing. In the last lecture, I explained about how to create a ladder logic with the simple bit level instructions, and in today we will discuss about how to follow a simple basic rules while creating the ladder logic, and also what is the significance of the addressing. We will try to understand. So first we will look into the rules. When it comes to the rules, here simple rules are there. Input instructions, you can use them in a series as well as in parallel to form any logic, whereas the output instructions or coils, we say, can be used only in parallel but not in series. I'll justify how, why, and why we have to follow in this way. Next, third point. One input can be used in multiple times in one program, but when it comes to the output, cannot be used multiple times in one program. Input can be used multiple times, but output cannot be used multiple times. Next, input address cannot be used as an output address. When you are assigning an address to the input, you cannot assign the same to the output instruction, right? Similarly, when we are assigning an output address to an output instruction, that can be used as an input. So we will understand all these points in detail. I'll give you an examples, right? So first, inputs can be in series or it can be in parallel. Yes, when you are designing the ladder logic here, normally you can use a normally open instruction, 2 instruction, 3 instructions or more. You can put them in a series followed by an output. Similarly, you can put them in parallel, right? You can put them in parallel. There is no issues at all, right? But when it comes to the output, we are not supposed to put them in series followed by like this. This is completely invalid, right? So you are not supposed to put these 2 output instructions in series, but you can put them in parallel. Yes, you can bring that instructions in parallel. So just below it, yes, you can. It means whenever this contact goes high, immediately that these 2 contacts will turn high. So the output status purely depends on this particular input instruction. Whereas in this case, it's very difficult to say that the output status of this, the status of these 2 instructions, we cannot able to figure out. So that's why this is invalid. Next, we discussed that the instructions in the ladder logic, one input can be used multiple times in a program. Yes, here in XOR, what we did, A B bar plus A bar B. Here in this logic, I used a normally open instruction for A and a normally closed instruction for B, then followed by a normally closed instruction for A and a normally open instruction for B, right? So this is XOR. Here I used this input instruction multiple times. So here I used A here and here. Similarly, B I used multiple times. So it's quite common that we can make use of the input instructions multiple times, right? You can use this instruction inputs multiple times, but one cannot, the output cannot be used multiple times in a program, in a one program. See why we should not use the output multiple times. So another example, it's example 4. Let's say AND logic followed by an output. For AND logic, I'm using A and B. Similarly, I have a OR logic as well, and for this OR logic again I'm using A and B. Okay, now followed by output. So coming to our point, what if we assign same address to the output? Now you tell me whether this queue need to follow AND logic or OR logic. It's an ambiguity, right? So there is an ambiguity that whether to follow this AND or OR. That's the reason why you are not supposed to repeat the output address multiple times, right? Now coming to our next point, here the input address cannot be used for an output instruction. Yes, that's true. Say for example, here AND logic followed by output A, B, and Q. Okay. Suppose I'm building a OR logic parallelly, A, B, followed by output. Okay. Suppose if I write A or B, then it's purely invalid. It means A and B defining the inputs. Here A and B are representing the inputs. If I represent that input in address across the output, then it's an invalid. So input address cannot be assigned to outputs. Right? Input cannot be assigned to output, but the vice versa is possible. Output address can be assigned to inputs. How? Let's see. I want to design a NOT, simple NOT. So what I'll do, first I'll take a normally open instruction followed by output. So A followed by output B, the Q. Then I'll take one normally closed contact followed by an output. This time I'll give address as Q1. Here what I'll do, this output address I will assign over here. With this, what happens when this input is turned high, when the input it is true, the output Q will go high. Immediately based on the status of this output, here then this input instruction will change. So what happens when this output goes high, immediately this instruction also will respond. So this instruction also becomes open. So normally closed becomes open, and here the output will be off. Understood? So if this is high, here it is 0. If this is 0, it means the Q status is 0, and here unchanged, no change, and here the output is high. Got the point? So you can use the output address to the input instructions, but input address cannot be used for the output instruction. Clear? So if we follow these simple rules in the ladder logic construction, then there won't be any difficulty, and you won't be end up with the error programs. Clear? Now next, move on to the addressing. So what is the significance of addressing of an instruction? Right. Basically, address are categorized into 3. 1, input address. 2, output address. And 3, memory address. Right? So what is input address? The input address or output address, I can say these two are physical address. Which represents the physical terminal channels. Say for example, I have one input module across the PLC. I have an input module, and this module has 4 digital inputs. Let's say 4 DI. Okay, 4 channels. 4 channels, right? Now, similarly, I have 2 DQ, 2 digital outputs. Clear? So, when it comes to the sensor interfacing, I have connected my sensor to channel number. This is my channel 1, 2, 3, and 4. I connected my sensor to channel 2 and 4. Similarly, I have connected my output to the second one. Okay, so this is the first one, this is the second one. So now Physically, I used 2 terminals out of 4 across the input side, and I used 1 out of 2. So now the same I need to represent across the logic. So when I'm constructing a ladder logic here, I need to follow the same. So I want to implement AND operation for my switching. So here what I'll do, this sensor 1 and this sensor 2, or a switch 1 switch 2, these are connected to address 2 and address 4. So I have to mention 2 and 4. If you consider this as an address, right, so you need to mention that over here. Otherwise this instruction, I mean, it is an ambiguity that I mean, like from where to follow, right? So this 2 and 4 you have to assign across this channel. Similarly, when it comes to the output, you have 2 outputs. So where you want to send your information, to channel 1 or channel 2. I have connected to my channel 2, so I have to specify 2 over here. So when you write these instructions specifically, then for input address the prefix starts with I, for output address the prefix starts with O. So it's very clear that I can write I2 or I4, which represents input 2, input 4, and output I can write O2. So output 2. Clear? So in this way, whenever I use this physical channels, these physical terminals, I will be using this physical address, right? Sometimes for the logic, we need to store the output, or we need to hold, or we need to put the information in some temporary in some memories. Okay, it need not be, I mean, like I'm not interested in sending the output immediately, so I want to hold that, and I want to do some more processing for a decision to be made. So what I'll do, I'll make use of the memory addresses. So what the memories will do here, simple. So memory, the prefix is M. Memory, the prefix is M. So now what I'll do, here this output, instead of this sending as out, I'll put it this one into the memories. I'll push this into the memory. So memory, you have the storage. So I'll push this to memory too. Okay. So what happens now? The status now currently it is moved to the memory, but not to the physical terminal. Right, as I said, because just based on the AND operation, I don't want to take a decision. So I want to confirm with some other logic. So what I'll do, I'll take the another confirmation, say I 3. I'll take the confirmation from another sensor, right? So what I'll do, this time I may connect to 3. So this is a sensor 3. Okay, so this is sensor 3. Now based on the sensor 3, and also based on my previous operation, right? So with this, what happened now, I2 and I4, when both are high, then only M2 will go high. Now when this M2 goes high, immediately the output instruction can be used across the input. So along with this M2, I'm checking with I3 as well. Understood? So based on this, I'm going to generate the output. So O2. Got it? So here what I did is the temporary, I mean I2, I4 result I'm putting in M2 memory. Later I'm using that memory, and again I'm comparing with the physical address. So once the decision is made, then I'm sending it to the O2. Right? So these memories will help you in many ways, like in later sessions, in some logics, in some process, we need to do some math operations, so we need to perform some calculations, right? After doing some math operations, then you need to do some decision need to be made. Sometimes we may use comparators, so we need compare the data. So based on the comparison, again the result, I mean, we need to take the decision. So for this purpose, memories will help you a lot. right? And when it comes to the addressing, each there are different makes of the PLC: Siemens, Allen Bradley, Schneider, and so on. Every manufacturer will follow their own system, right? It's like what we're discussing here is a generic ladder logic programming, right? So the same format may not be used in the Siemens or in Allen Bradley, because they have their own way of addressing. So when you look into the Siemens PLCs, their addressing format will vary from Allen Bradley. Similarly, when you come to the Schneider or any other PLC, the format will vary. So it's up to the it's up to the manufacturer specifics. So that's why I'm not biased to any particular device. So I'm just giving the general examples over here. So how to give an address. So what is a physical address and what is a memory address? I'm just giving some general insights about this topic, right? I hope you understood the significance of the addressing. And one more point, if you miss the address, say for example, you're writing a ladder logic and you missed out the address, right? So you missed out the address. There is no address at all. Every time whenever you place the instructions in the application, so there is a question mark which appears. So if you miss the address and you are proceeding for the next step, then it is invalid. So without an address, your ladder logic is invalid and it is of no use. Understood? So must and should, you need to address them properly, right? So if you don't address, or when you are giving your response to the in the examination or anywhere, so if you miss the address, and only if you are putting the instruction in a proper way in a series or parallel combination, doesn't make any sense. You have to give a address as well. Understood? So that is the topic about the addressing, and I hope you understood what is the significance of addressing and why we should do the addressing. And also I hope you understood the rules, so how to construct the ladder logic, and based on the simple rules which we discussed today, right? So thank you, and we'll continue in the next lecture.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.